But what about the natural resistance to the progress of electrons? Just what is the nature of electrical resistance? Under the influence of an electric field, electrons move through a metal much as a marble falls through a viscous fluid. If it weren't for resistance, they would accelerate freely, like a falling body in a vacuum. But as it is, they move on the average at a constant speed. Resistivity is like viscosity. The more of it a material has, the slower a particle will move through it. But what slows the electrons down? In other words, in a conductor, what resists the flow of electricity? Inside a metal, electrons constantly move in all directions. Here, just a few of them are represented as dots. They orbit through the metal as if it were one giant molecule. This kind of flow encounters no resistance, nor does it create a net flow in one end and out the other. Under these conditions, the conductor is in electrostatic equilibrium. There's no electric field inside, no voltage difference from one end to the other. But if a battery makes an electric current flow, equilibrium is destroyed, and an electric field is created inside the conductor. Inside a perfect crystalline metal, if a sample of it could be found, the mobile electrons would continuously accelerate, like a penny falling in a vacuum. But in the real world, crystals aren't perfect. They have defects and impurities, and their atoms vibrate with thermal energy. Electrons, accelerated by the force of the electric field, bounce off each imperfection, behaving somewhat like a ball in a pinball machine. All that bouncing, all that stopping and restarting, produces the resistance that prevents the electron flow from building up speed. So the electrons move at a constant average speed, creating a constant current under the influence of a constant force. As the electrons bounce off the imperfections, they set the atoms into larger vibrations. So the electrical energy of accelerated electrons turns into the heat energy of vibrating atoms. And about 100 years ago, a brilliant idea rose from that heat. If a resistor gets hot enough, it will glow. And Thomas Edison found just the right materials that would glow brightly.